The 9th of July, 2025, was the shortest day in recorded history. Nobody felt it. Nobody could have. It ended about a millisecond and a half early, a thousandth of a second, and then a bit more. You blinked several times slower than that while I was saying it, but in laboratories around the world, more than 450 atomic clocks noticed. They are the most precise instruments our species has ever built. They keep time by counting the vibration of cesium atoms, and they do not care what the sky is doing. And what they have been quietly recording is that the planet they sit on has begun to run ahead of them. For the whole of the 20th century, Earth was running slow and getting slower. That was the settled story, and we built our timekeeping around it. Then, about a decade ago, the planet started speeding up. It is now spinning faster than at any point in 50 years of measurement. And the reason is not the moon, and it is not the weather, and it is not anything on the surface. It is 1,800 miles beneath your feet. There is an ocean of liquid iron down there, and it is slowing down. And because of that, you are speeding up. By the end of this, you'll understand why those two sentences belong together, and why the only thing standing between us and doing something to the world's clocks that has never been done before was melting ice. Start with what a day actually is, because we changed the definition and most people never heard about it. For all of human history, the day was the clock. Every timekeeper we built was checked against one thing: how long it takes this rock to turn around once. Then in 1967, we swapped it out. The second stopped being a fraction of a day and became something else: 9,192,631,770 vibrations of a cesium atom, a number with no sky in it. Our clocks were no longer measuring the Earth, they were measuring something better, which immediately created a problem. The atom is steady, the planet isn't. So the two drift apart, and to keep them holding hands, we invented the leap second. Whenever the Earth fell about a second behind, timekeepers added one back. For a single moment, official clocks would read 23, 59, 60. A minute with 61 seconds in it. Since 1972, we have done this 27 times, and every single one was an addition. 27 times in the same direction for the same reason. The Earth was slow, and then they stopped. The last one was added at the end of 2016. There hasn't been one since. Not because we changed the rules, but because the Earth stopped needing them. It caught up, and then it kept going. Now, when this made the news last summer, the moon got the blame. And it deserves some of it. When the moon sits at its furthest from the equator, it pulls on the planet slightly off-center, and that nudges the spin up for a few days. That is genuinely why the 9th of July was the record, and why the 22nd and the 5th of August were close behind. But hold on to this, because it's where almost every explanation of this story goes wrong. The moon explains the spikes, it does not explain the trend. Those are weather. Something else is the climate, and to find it, you have to go down. 1,800 miles beneath the ground you're standing on, the rock ends. Below that boundary is the outer core, an ocean of molten iron and nickel, roughly as hot as the surface of the sun, more than 1,000 miles deep. It moves. It has currents and storms and slow overturning rivers, and that churn is what generates Earth's magnetic field, the thing that keeps our atmosphere from being stripped away. Everything you have ever cared about sits on top of it. And here is the part worth slowing down for. The Earth is, for our purposes, a closed system. The total amount of spin in it has to go somewhere, one of the oldest and least negotiable rules in physics. And the core and the rock above it are coupled. Magnetically, gravitationally, they push on each other. So if the liquid core loses some of its rotation, that rotation doesn't vanish. It moves outward, into the mantle, into the crust, into the ground under your feet. In 2024, a geophysicist named Duncan Agnew published a paper in Nature that pinned it down. He took the observed rotation of the planet, stripped out everything else that tugs on it, oceans, atmosphere, ice, and looked at what was left, and what was left was astonishingly clean. Since 1972, the angular velocity of Earth's liquid core has been decreasing at a constant rate, and in his words, that has steadily increased the angular velocity of the rest of the Earth. Read that again with yourself in it. You are not a passenger. You are the rest of the Earth. You're standing on the outside of a flywheel, and it is winding up because a sea of molten metal 1,000 miles thick is winding down. That has happened every day of your life, and it will happen while you sleep tonight. One caveat, because you may have seen the other headline. There's a separate finding, also 2024, also Nature, that Earth's solid inner core has slowed enough to be moving backwards relative to the surface. That's real, and it's a much smaller effect, around 1,000th of a second on the length of a day, which, as one researcher put it, is almost lost in the noise. Two pieces of the core, two stories. The one rewriting our clocks is the liquid one. So the core is speeding us up, which raises an obvious question. If it's been doing that steadily since 1972, why haven't we had to delete a second already? The answer is the strangest thing in this story. Something has been pushing back, and it's the ice. Think of a skater. Arms tucked in, they spin fast. Arms extended, they slow. Mass moved outward, away from the axis. Greenland and Antarctica are the tucked-in arms. As their ice melts, that water doesn't stay at the poles. It spreads across the world's oceans and ends up preferentially near the equator, the widest part of the spinning object. Mass moves outward, the planet slows. And this isn't inferred. It's measured directly by satellites that map the planet's gravity precisely enough to weigh the ice as it leaves. When Agnew put the numbers in, he found the ice has been slowing Earth fast enough to partly cancel what the core is doing. Take it out, and the world would have needed to subtract a second from official time in 2026. That's this year. Instead, the projection is 2029. His paper contains one of the more remarkable sentences in modern geophysics, that global warming is already affecting global timekeeping. Sit with the shape of that. There is a river of iron 1,000 miles down trying to speed the planet up, and meltwater at the equator trying to slow it down, and the argument between them is settled in thousandths of a second. And the outcome determines what time it is, not metaphorically, what time it is on your phone tonight. Which brings us to what subtracting a second actually means, and why the people whose job this is have quietly been dreading it. Every leap second in history was an addition, an extra tick. A negative leap second is the opposite, 23, 59, 58, and then straight to midnight. A minute containing 59 seconds. It has never happened. Not once since we started keeping atomic time, and the honest problem isn't the physics, it's us. At the end of June 2012, a positive leap second, the easy kind, the kind we'd done 24 times already, hit a bug in the Linux kernel and took down Reddit, LinkedIn, and Qantas's booking system, stranding passengers at airport counters. That was for a second we added. There is essentially no production code anywhere that has been tested against a second being taken away. Some companies gave up on handling it properly at all. Google's fix is to smear the leap second across an entire day, stretching each second a fraction so no machine ever sees a number it doesn't believe in. Now, you'll have seen headlines saying this could bring down satellite navigation. It won't, and the reason is a good one. GPS never adopted leap seconds. GPS time has run continuously, without a single interruption since January 1980. It's currently 18 seconds ahead of civil time, and nobody minds, because the receiver in your pocket knows the offset and corrects for it silently. The satellites are fine. They solved this by refusing to play. The real exposure is far more ordinary. Databases that assume time only moves forward. Log files that have to be put in order. Financial systems time-stamped to the millisecond. Nothing cinematic, just an enormous amount of infrastructure built by people who reasonably assumed a minute has 60 seconds in it. So there's a decision to make, and it's being made in a room. On the 13th of October this year, at Versailles, just outside Paris, the General Conference on Weights and Measures, the body that has governed the world's units since the Meter Convention of 1875, meets to vote on retiring the leap second altogether. The proposal is to let atomic time and the Earth drift apart, uncorrected, for far longer, to tolerate a gap of up to an hour before anyone intervenes, which hands the problem to a committee generations from now, along with a leap hour. The odds we ever actually need a negative leap second before 2035? About 30%, says the head of time at the International Bureau. About 40, says Agnew. That's not a crisis. It's a coin flip nobody wants to be holding. But step back from the engineering, because there's something larger here. For thousands of years, time was the Earth. A day meant one turn of the ground. Every clock we ever built was a device for imitating this planet. And the better the clock got, the more faithfully it copied the rotation beneath it. And then, somewhere in the last 50 years, we crossed over. The copy became more reliable than the original. This October we may formally admit it. Time will no longer mean the turning of the world. It will mean the vibration of an atom, and the planet will be politely allowed to fall out of step with the standard it used to define. We didn't build a better clock. We built a clock so good it stopped agreeing with the thing it was built to measure. So I'm curious where you land on this. If the Earth and the clock disagree, do you fix the clock, or do you let the Earth drift? Tell me below.